I'll be explaining about our introduction. Image thresholding is a fundamental technique in image processing used to be separate an object from its background. It converts a grayscale image into a binary image based on the pixel intensity. However, real-world images often contain noise, uneven lighting, and overlapping entities, and making classification difficult. Classical methods like Otsu use a single threshold which may not handle ambiguity well. To address this, fuzzy logic is introduced, allowing pixels to have two degrees of membership rather than strict classification.
Next, I will explain the method used in this project. This project compares three different image thresholding methods using the same grayscale image to evaluate their performance. The first method is Otsu method. This is an automatic threshold technique that calculates the optimal threshold value by maximizing the variance between the foreground and the background. In simple terms, it automatically finds the best point to separate the objects from the background without requiring any manual inputs. The second method is fuzzy thresholding. Unlike the Otsu methods, this approach uses a membership function to assign each pixel the value between 0 and 1, representing how strongly it belongs to the foreground. The membership value is calculated using the formula shown on the slide. A pixel is classified.
Right. All three methods were applied to the same plant images, which were fairly uniform background. That made segmentation straightforward across the board. Starting with Otsu method, it successfully separates the plant from the background, giving it a clean binary result. This fuzzy method produces a similar segmentation to Otsu, so visually the two are hard to tell apart. And then the intuitionistic fuzzy result is visually identical to the fuzzy method. This actually makes sense mathematically, since our non-membership degree was just the complement of membership. The hesitation degree collapses to 0, so two methods end up applying the same effect threshold. So to conclude, all three approaches generate a clean silhouette with clear, well-defined object boundaries, and given the strong contrast between the plant and its background, this is relatively easy segmentation case. The relative advantage of fuzzy intuitionistic fuzzy method will show up more clearly on images with less contrast and more ambiguous boundaries. That's all.
The similarity between methods come from the simplicity of our test. In our implementation, we set non-membership v equal to 1 minus mu x, which means hesitation x pi x is 0. The intuitionistic fuzzy set model simplifies down to score 2 mu minus 1, which really the same as just checking if mu is greater than or equal to 0.5. In other words, for the case, IFS doesn't give us any real advantage over the simpler fuzzy method. That said, each method still has its place. Otsu method works well for simple image with clear separation. Fuzzy method helps when the more uncertainty involved. The IFS needs a more advanced non-membership function to actually be useful. Overall, fuzzy appearance tend to perform better on real-world image where ambiguity is more common.